In this video, you're gonna be building SushiSwap in Next.js. We're gonna be using Solidity. We're also gonna be using Infura to build this app on the Ethereum blockchain. We're also gonna be using RainbowKit to connect our MetaMask. This is gonna be an amazing build. Let's just get started. All right, now let's go ahead and get started building the SushiSwap clone. So as always, we're gonna be using the custom CLI tool that we built for you. So just pop in your email name and then just start typing in SushiSwap. It should show up and hit return on it and then let it do its thing. Now it will also open up Infura for you. So go ahead, log in or make an account if you don't have one already, and then select Web3 API as network and then just name it SushiSwap or whatever you want to. And then in the meantime, likely the CLI tool will be done and we'll open VS Code for your convenience. So just full screen that and go back to Infura. You should be good to go there. No need to worry about it. So finish setting up your Infura project and copy your API key, and that should be pretty much your first step. All right, now as your first step, what we're going to be doing is we're going to be creating a custom token. So let's just get started. So inside your contract/custom dex SOL file, you can start typing it, and just like with any Solidity file, you will need an SPDX license identifier, which is going to be MIT. And we are going to be working on the 0.8.0 version of Solidity. So just use that. And right at the gate, we're going to go ahead and import some OpenZeppelin contracts and libraries. So the first one is going to be the ERC20. And we're also going to be importing the SafeMath library. Let's just do that. And now we're going to go ahead and actually create the contract, the token contract itself. So as usual, we're going to be building on top of the ERC20 library, and we're going to have obviously the name and the symbol of that token. So let's just build out the contractor with those and then create the minting function. So that will look like that. You're going to pass in the account and the amount and that is pretty much it. We're just going to get started with the custom DEX in a little bit. All right, let's build the first step for the custom DEX. So we're going to be using SafeMath in here. So let's just import that. And now we're going to do a couple of pre-steps or whatever they are called. So we're going to go ahead and create an array of strings. And we're just going to put in the names of the coins. So you can rename those coins however you want to. I'm just going to call it coin ABC. And now I'm going to create a mapping. So later on, this is going to be useful. So what we're going to be doing is we're going to be mapping the actual ERC instances to these coin names themselves. So mapping string to ERC20, and it's going to be public. And then we're just going to name it token instance map. These are going to be the conversion values. So one custom coin will cost you 0.0001 ETH, and then one coin will cost you 1 coin. So this is just for later for reference. And the DEX's constructor will be a for loop. So what we're going to be doing is we're going to loop through the array that contains the names, and it's just going to basically run the coin constructor itself. So basically just generate a new token for you. And then we're going to be minting a bunch of them into the contract address itself. So that's what address this means, meaning that all the coins that are going to be minted in this step are going to be minted onto the contract itself. So nobody's actual wallet, it will be minted onto the contract. So the contract will own all the tokens. And you just want to put in like a big number, like a huge number. That's because you don't want to run out while you're testing. Just put in as big of a number as you can think of. And then what we want to do is we want to save this token into the token instance map, just so we have access to it later and we can access it. So once you're done and your contract looks like this, you are pretty much good to go. Okay, now for the next step, we're going to be implementing the getBalance function. So let's just get started with that. And that'll have 2 arguments. One of them is going to be token name, and the other one is going to be _address. So basically when you call this function, you should pass in coin A and then whatever your own wallet address is. So this function will return the balance in the given wallet of the given token. So this will be a function that will return a number. And so the only thing that we will have to implement is returns token instance map, pass in the token name, and then balance of, and then the address. So if you, let's say if you have 5 coin A tokens and you pass in coin A and your own wallet address, it should return 5. So that is pretty much the get balance function. All right, let's test all the functionality that we implemented so far. So first of all, what you want to do is start your Remix server on in your VS Code. It's just a free Ethereum Remix extension. And what you want to do is, if you don't have Ganache installed, go ahead, obviously install Ganache and spin it up. And then just make sure that the ports are matching so that it connects. And once you're done with that, you can go ahead, hit compile, and then hit deploy on your customdex.sol file. And there you go, you will have the instance right there. And there will be an issue, which I forgot, because when you import from OpenZeppelin, you should import from contracts as in plural. So just go ahead, fix that, redeploy the contract, and then you should be good. Now, once you're in there, you will see all these functions that you can call. So let's just go ahead and start checking out if we have all the tokens. So the first item is going to be coin A, coin B, coin C. So that works. And then now if you want to test out get balance, like I said a minute ago, you can just pass in coin A and then the address, which is in case it's going to be the contract address itself. And you should just get back the initial number of coins that you minted onto the contract. So you see those bunch of zeros after a 1. So that means this functionality is working. So with that said, let's move on. All right, now let's make a function that actually returns the address of the coin. So function get token address, you will pass in a token name and then it will return an address. So what we're going to say is return address, token instance map, and the token name. That's literally all it is. Now let's go ahead and test it. So I'm just going to go ahead, redeploy the contract, and let's try it out. So I'm going to pass in coin A in there, and there is your address. So that is pretty much this function. All right, now actually let's start swapping ETH to these custom tokens. So what you want to do is just create a brand new function, and we will be passing in token name, because now this is where you're going to pass in coin A, B, or C, or whatever. This is going to be a public payable function that will return a number. So first of all, let's create a variable and let's just store however much ETH was sent to the contract. So input value equals message.value. And now what we're going to say is output value. So basically the amount of coins that we'll be sending back to the user. We'll be calculating that by saying input value.div, and this is coming from the safe math thing. So basically we'll divide the input value with the ETH value. Now, ETH value, you can just create another variable somewhere outside of this function and then just give it a value. Totally doesn't matter. Just make sure it's in way. And then we're going to be multiplying that by 10 to the power of the token instance map, like however decimals we have, with the token instance map token name dot decimals. So these are all things that are coming from the safe math. So just feel free to pause the video, check out what it is doing exactly, and then continue from there. And next up, we're going to need to require that we are able to actually send that money, so that we have the funds in the contract to send back the output value to the user. So that's going to be a requirement. And then we're just going to be returning the output value just so the user knows, okay, this is actually how much you can go ahead, check your wallet. Now, mind you, on line 54, I have a typo in the required. So just be mindful of that. This test will fail, but let's go ahead and compile. There you go. There's the error. So hit compile, deploy the contract, and let's go ahead and test it out. So swap ETH to token. I'm just going to say coin A, and then you have to pass in a value there. So I'm just going to say ether 0.0001, whatever. And I should technically, I think, be getting 1 coin A. So that should be somewhere there. So I'm just going to paste in my wallet address, and there it is. That's the amount in way. So that's literally one piece. All right. So with that said, now let's go ahead and swap tokens to ETH. All right, so now we're going to be swapping tokens back to ETH. So let's create that function. We're going to be passing in the token name and the amount, and we're going to be returning obviously the amount of ETH the user will get. We're going to need to do some conversions here first. So we're going to say UN256 exact amount, and we're going to be dividing the amount that we're sending to the user, or the user sends us. So basically the user sends us in WEI, and we will have to convert it to ETH. So we're going to be doing that there. And now we're going to be saying ETH to be transferred exact amount multiplied by ETH value. So the user sends us their coin in the value of WEI. We convert it up to ETH, and then we're going to be multiplying that with the conversion rate. So after this, once this is done, we're going to need to make sure that we are able to cover that transaction. So the contract has to have enough ETH balance. Otherwise, this transaction cannot go through. If that requirement is met, we will just go ahead and transfer the ETH that we need to transfer. So that will happen through this. We're going to say token instance map, token name, transfer from the message sender, basically the user. We're going to be sending the amount that they are sending to the contract, and we're going to be storing it. And after that, we're going to be sending the ETH back to the user. So with that said, we're just going to return the value, and that is pretty much this function. Now, mind you, this function will need to be confirmed by the user. We'll collect that on the front. So now with that said, there's only one thing left to do, and that is to create a token swap function. All right, so the last thing we need to implement here in the contract is actually the token to token swap. So let's create the function, and we're going to have to pass in the source token name and the destination token name. So basically, which token do you want to convert to which token? And then obviously the amount. Now, this will be a public function, and we will need to make sure that both the source token and the destination token has enough balance in the contract to cover this transaction. So once that is done, we're pretty much basically good to go, and inside the require function we can just get done the transfer immediately. And obviously this will need to be approved by the user, which again will be done on the front end. So with that said, now let's go ahead and deploy this contract. Okay, so go into your Truffle config, and then whatever is inside your networks, just go ahead and get rid of it. It's not really necessary. And once you're done, just go into your Truffle and connect to a network. Now, as I said earlier, we're going to be using Infura. Connect to Infura, and your SushiSwap project that we created at the very beginning of this tutorial should already show up. So once that's there, you click it, you're good to go. It pretty much connects your VS Code to that SushiSwap project. And now if you start deploying the project you can just say right click and then hit deploy. You just select the SushiSwap Girly network, and then you should be good to go. It will get started everything for you. Now it will take a little bit to deploy, but just wait for it, and you should be pretty much ready soon. And there you go. If you see your contract address at the end, you are good, and the project has been successfully deployed. And once you're done deploying, we're going to be doing a couple of things to get our front end ready for this project. So go into your build/contracts folder and just copy your custom dex.json file. We're going to be using it in a little bit. And now go inside your source folder and just create a new folder called utils, and then just paste it in there. And now we're going to go ahead and copy the custom token.json file and paste that there too. We're going to be using that in a little bit. This is the ABI. This is what will help our front end to interact with the contract. Now, once that is done, just go ahead, create a new file, contract.js. And we're going to be importing ethers, because in this project, we're actually using ethers. And now you're going to go ahead, import custom dex ABI, the file we just copied, and the custom token ABI, the other file we just copied. So we're just going to import both of those. And now we're going to create a couple of helper functions that we will be taking advantage of later on. So we will need to create two functions, one for the token and one for the DEX itself. So we're going to say export const token contract. It'll be an async function, and we'll create a provider, Ethers provider, Web3 provider, and then we're just going to pass in window.ethereum. Don't worry about that part, that stuff. If you have MetaMask installed, the Ethereum object will be immediately injected into every single website you visit. And now we're going to deconstruct Ethereum out of window, and we're going to be working with that. Now, you will need to create a signer, which is going to be provider.getSigner, and the provider, again, 2 lines above, that's where it comes from. We're going to also create a contract reader. Now, this is something that is only possible with Ethers.js. So we're going to say new ethers.contract. We're going to pass in the address that will be created with the DEX. And then we're going to pass in custom token ABI, because inside your file, there is a bunch of things, but we need the ABI. So that specific part of the object. And we're also going to pass in the signer. That will help us later on with all the transactions. And we're going to go ahead and return the contract reader. Now, we're going to go ahead and repeat this exact same thing for the DEX contract as well. So the only difference we're gonna have is we're just gonna hard code the contract address. So that comes from your output. And now we're gonna pass in the custom DEX ABI and with the signer. So with that said, we are pretty much good with this part. Let's move on to the next. All right, so now we're gonna go ahead and set up 2 conversion functions. So inside utils, just create a new file, ethers-utils.js, import ethers, and we're gonna be creating a 2-way and a 2ETH function. And these are literally just going to convert, as the name says. Export function 2-way, amount decimals, and decimals by default is gonna be 18. So you're gonna pass in the amount you want to convert 2-way in ethers, and then just use the library. So ethers.utils.parse units, and then it will just do the conversion for you. So you don't even have to worry about that. And then just return the string version of that number. And then this is going to be the exact same thing, but in the other direction. And instead of parse units, we're going to use the format units method from the Ethers library. So that's pretty much that function. Now let's actually set up the MetaMask wallet connection as well. So I'm just going to spin up the app and let's take a look at it. So right now this is how the app looks like, and there's your connect wallet button not working so far. Let's take a look at what's happening. So inside of app.js, that's all your imports and wagmi config and everything. So as you can see, it requires Infura to connect to the blockchain. So copy your API key and go back. Now you want to obviously put it in your env file, and then that will make RainbowKit work perfectly. That's literally the only thing you have to do. And now let's just render out the connect wallet button. And as you can see inside of header.jsx down at the bottom, you can there's a static connect wallet there. So let's just go ahead and replace that with MetaMask. We already pre-built this component for you, so you can just use it, and that will go ahead and take care of your wallet connection. If your wallet address shows up at the top where the button was, you are good to go, and you can disconnect, connect whatever wallets you want to. So with that said, let's go ahead and implement the conversion functions, and we're done. Let's go ahead and create a new file in the utils folder, and this is going to be a queries.js. We're going to be importing big number and ethers from ethers, and contract and token contract from contracts. So this is what we're going to be using, by the way, to just get the ETH balance. Also, let's import 2 ETH from the ethers utils file that we just created. So we're going to say export const get balance. This is going to be an async function. We're going to pass in the wallet address and the usual try catch. So if there's an error, let's just console log it and see what's up. And then in a try, we're going to have a transaction that's just going to convert the value or whatever amount. So we're going to make sure that our wallet is connected, meaning the ethers is not undefined. After that, we're going to go ahead and create the provider, how we already created multiple times. And now we're going to go ahead and get the user's balance. So we're going to grab the account. So all the accounts that are connected to the app. So await provider.list accounts, and the user's account is very likely the first one that is being connected, and that's usually the active one because MetaMask sorts it like that. Now, next up, the balance in way is going to be provider.getBalance, and then we're just passing the user address. And now we have to convert that into ETH. So we can use either the toETH function that we created, or we can just type it out again, and then we're going to be going to returning it. However, if you remember, this is going to be a big number, so later on we'll have to deal with this. So let's go back to our index.js, and in there we're going to be handling the balance. So this is going to be an async function, and this is going to be useful later on, but basically when you try to swap, you will have to select the source and the destination token, and so that's what's going to get passed in here. So if one of the tokens that the user wants to interact with is ETH, we'll have to get the ETH balance of the user and then display it. I'll show it to you in a little bit. So if the first drop down is going to be ETH, we're going to need to go ahead and get the balance of that. And actually to do that, let's grab the connected wallet. So use account from WagMe, and then let's just save it. So we're just going to pass it in there. And then we're going to be setting the first balance to that balance, and we're going to convert it to a number and then cut down, or attach two decimals. If it's the second drop down that is selected as ETH, we're going to literally just repeat the same exact function, but we're going to be saving it in obviously the second balance use state. So now what we need to do is pass it into these coin drop downs. As you can see, we already have it highlighted for you. So just find those two and then replace the string with the function name itself. So just you can remove the apostrophes and then you should be good to go. Now, if you run this app, it looks like there's some sort of an error in our contract.js. So let's check it out. And it looks like that we imported the wrong file. So we need to import custom dex.json, not custom dex API. All right, let's see if it works. So I just selected ETH and it doesn't seem like it's working. If you see, the balance is still 0, which is not ideal. So let's take a look at what's happening. And apparently when we are selecting anything, we are not running the function itself. As you can see, it's not even like completely white. It's like this grayish color, which means that VS Code is recognizing that we're not calling that function. So let's just pass it in there, both in the first drop down and then the second drop down as well. So with that said, now this should work. So if I'm selecting it, and there you go, it updates. So as you can see, now it shows up as 4.54 ETH over there. So that looks good. Let's move on to the next step. Okay, now let's repeat that same process, but for the custom token. So inside of queries, we're going to have another function that will get the custom token balances because we have to handle those differently. So we're going to say get token balance, and then we're going to pass in the token name and the wallet address where we're interested in the balance. So we'll have the contract object, which will be coming from the contract file. And then we're going to use the getBalance function that we actually wrote in the contract, and then passing token name and the wallet address. After that, we're going to go ahead and return the balance. And again, this is going to be a big number. So let's go back to index.js, import get token balance from this function or from this, and write down at handle balance. Let's just add an if else statement in there. Let's go into the else statement and another if statement in there. And so if it's the first drop down, then we're going to get it for the first drop down. If it's going to be and set it as the first balance, we're going to be using we're going to get the balance using the freshly created function. And then because it's coming back in way, we'll have to turn it into ethers. And then we're going to be set it as the first balance. And then we're going to repeat the same process, but for second drop down with second balance. Now I'm going to go ahead and cut this out. So it's going to disappear in a little bit. And then we're going to add a try catch function. That's just good practice to do with blockchain apps. So let's test out if it works. And it looks like there are some errors. That's because the address seems like it's off So that's probably because the use account dot address is how we're going to get back the address. Add that there when we're trying to get it from WAGMI. And now it seems like the ethers package has not been imported. So let's do that because that looks like it's going to be useful. And as you can see, now it works. So ETH is getting fetched and then we don't have any Bitcoin. So it returns 0. We don't have any Solana. So that returns 0 as well. That looks like it's working. Now let's work on the swap functionality and we should be good. Okay, so let's actually swap from ETH to custom token. So let's create the function, pass in the destination token name and the amount of ETH you will want to convert, usual try catch. And then we're gonna create the transaction value, which is, we're gonna figure it out by converting the amount from Ether to Wei and then saving it in a object. And we're going to create the contract object using the contract function we've already created. Then we'll create the data, which is going to be await contract object, swap ETH to token, and then pass in token name and the transaction value. Then that will generate a receipt once we wait for it. So let's return that. And then this function is essentially done. Go back to your index file, import this function. And now we're going to handle it. So handle a whole swap. So try catch. And if either of the inputs are empty, or if the first input is empty, we're just going to return because there's nothing to do then. And if the transfer coins from value is ETH, meaning the first value is ETH and the second value is not ETH, we're going to be running this function. So we're going to get the receipt from the freshly created function. And then we're going to say, transfer coin to backend value and first input. These are the arguments we're going to be passing into the function. So the first one is going to send the name. The second one is going to send the value. And there is the function being called in that when you hit that button. All right, so that should in theory work. So I'm just adding numbers, but it doesn't work yet. Now we're going to implement that it automatically calculates how much you will be getting by sending the X amount of ETH. All right, so we're going to say handle output. That will return that value. So usual try catch. And we're going to make sure that the first input is not empty. And then we're going to be, if the first one, the transfer of the destination coin is not ETH, and like we're going to make sure that it is an ETH to coin transaction. And if so, we're going to calculate the output value, and that will be we're going to get the first input, convert it to Wei, and make sure that we pass in 14 decimal digits, and then convert it to ETH. And then we're going to convert it to number and add 2 and no decimals and set it as the second input, and that should, in theory, get it all done. Now, we're going to run this same functionality if the values are changed up. So if we want to transfer from custom token to ETH, otherwise it's literally just the same value. So if it's ETH to ETH, obviously it's going to be the same value. If it's token to token, because their value are equal, it's going to be again the same. That is good. And up there in index, we're going to be adding a new use effect that will basically just update the output value every time either we change one of the drop downs or the input boxes. So let's test it out. And it looks like that two-way is not defined in index.js. So let's go ahead and import it. Apparently we forgot it. And now let's just put in random values. Let's see if it works. And it looks like it's looking. So if we try to trade, it looks like two ways again not being defined. So apparently we have to import it into queries.js as well. And now it looks like the conversion from ETH to custom token is working perfectly. So with that said, let's move on to converting back. Okay, so before we are able to swap back to ETH or between tokens, we'll need to add something called an allowance, and that basically just allows the app to do these sort of transactions. So in our queries, we're going to need to check for this allowance. So we're going to create a function for that, and we're going to pass in owner, token name, and amount, usual try catch, and then usual contract object, get the address of the contract or the token. So contract object, get token address, pass in token name, and we're going to create a token contract object. It's just the usual drill. And for the transaction data, we're going to be saying that token contract object allowance, pass in owner, and the contract address. And then we're going to save the allowance, and we're going to generate a big number from the data that's being returned. We're going to convert that to way. And then we're going to check if it's 0 or below the required amount. If yes, then we're going to return false. Otherwise, we're going to return true. And now we're going to import that has valid allowance function into our index. And in our handle swap, we're going to create an else statement, and we're going to check if we have allowance for the transaction to go through. And by passing in the current account and as the owner, transfer coin from as in the token name and then the value. If it returns true, then we're good and we can go ahead execute the transaction. Otherwise, we're gonna have to just console log no user allowance for now, and then in a little bit we're gonna increase the allowance. So let's see what do we got. Apparently, we wrote that decimal value to the wrong place. So let's fix that real quick. All right, let's see what we got. And now it shows that there is no user allowance. So that's good because we never increased the allowance. So that's how it's supposed to work. All right, now go back to your queries, and now we're going to actually increase the allowance. So let's create a function for that. And usual try catch, pass in token name and the amount. And we're going to say contract object. In the usual drill, import everything, create all the objects and instances. So we're going to have the contract object address and then token contract object. And then with data, we're going to generate the usual stuff. So now the transaction data will be generated by calling token contract object dot approve, pass in the contract address and then the amount in way. So now it looks like it's still not running. That's because we haven't called it. So we will have to import it in our index, and where we console log no user allowance, we're going to have to call that function that we just created. Const receipt equals await increase allowance, pass in the token name and the value. And now let's console log what happens. And there you go. Now we have to confirm that we want to increase the allowance, and we should be good to go moving forward with converting tokens. Okay, so the last two steps are swapping tokens to ETH and then token to token. They are going to be very similar, so we're just going to blast through these and we're going to be done in a matter of minutes. Okay, so in our queries.js, we're going to be creating two functions. The first one is going to be swap token to ETH. Async function, we're going to pass in which token do we want to and how much of it do we want to. Usual try catch, and then just create all your objects, generate the data. However, the transaction data is going to be using the swap token to ETH function from the contract, and then pass in the required arguments, the token name and the amount in way, generating the receipt, and we're going to return that receipt. We're going to import this function in our index.js. And if the user has sufficient allowance, where we already wrote the if statement, we're going to be calling this. So let's remove that console log, and we're going to be just saying const receipt, and we're going to save that in a variable or a constant, and then pass in the required arguments, the name and the amount. And we also want to run it again once we increase the allowance. So there are two scenarios. One, the allowance is already there. We just want to run the transaction. Otherwise, we want to increase the allowance and then run the transaction so the user doesn't have to keep clicking. So that looks good. Let's go ahead, test it out. There you go. I'm increasing the allowance now. And now the swap is going through. So that looks amazing. Now let's go ahead and actually implement the token swap. So for that, we're going to have a very similar function in the queries.js, usual stuff. Now, the slight difference is that we are going to have a source token and a destination token. So we need 3 arguments instead of 2. We're going to generate the usual contract object, and then this is going to be a swap token. The token method that we're going to be calling, we're going to need to pass in both the source destination token and the amount, obviously, and we will generate the transaction receipt based on that and return that. Now we're going to be importing that in our index file, and so far we only have 2 types of transactions. One is when ETH is being converted to not ETH and everything else, but that's not the reality. So let's add another if statement in after the. So the second type of transaction that we're handling is the not ETH to ETH type of transactions, and now we just implemented the token to token, so the custom ERC20 token to custom ERC20 token type of transactions. So we're going to be doing the exact same thing. So we're going to check for a valid allowance based on the required arguments, and then if we have enough allowance, then we're going to run the function. Otherwise, we're going to increase the allowance, and that is basically the application. So once again, let's just test it out. Let's just see if everything works. We're going to go from a custom token to another custom token. We're going to go through the whole transaction flow. So now the token spend is approved, and now we're going to just reject it because it showed up as a duplicate. So we're going to go ahead, confirm it, and now the transaction is going through. That conversion is working. So with that said, thank you so much guys for following along. This was an amazing build. And with that, I'll see you in the next one. Peace.